So we're doing motion. There's a couple things we need to know before we start. So we need to understand what R, T, and D stand for. So R is my rate. It's usually a speed of some sort. T is my time in hours. And D is my distance. Okay, so those are the things we need to know before we actually get started. Okay, so knowing that, we're going to start. It says Chicago and Green Bay are about 200 miles apart. If a car leaves Chicago traveling towards Green Bay at 55 miles per hour at the same time as a truck leaving Green Bay bound for Chicago at 45 miles per hour, how long will it take them to meet? Okay, so drawing pictures is going to be your smartest thing here. Okay, I'm going to color code mine. You obviously don't have to, but that way you can understand where I'm coming from when we create our equations. So here we have Chicago and Green Bay, and we know that they are 200 miles apart. Okay. So then, that's that first sentence. It says, if a car leaves Chicago traveling towards Green Bay at 55 miles per hour, at the same time a truck leaves Green Bay towards Chicago going 45 miles per hour, how long will it take them to meet? Okay. So we have a rate of 55. Did it tell us the time? No, so our first unknown is always x. Okay, then we know that our second rate is 45, and it tells us the same time, so it's just going to be x again. Okay, now, if you notice on top it says rate times time equals distance, so 55 times x is 55x. 45 times x is 45x. Everybody okay with what I've done so far? Okay, so I want you to see that what represents my distance, since we're talking about miles down here, what represents my distance is 55x and 45x. Do you see that the green and the pink added together equals the purple? Because we're trying to, For this one, yes. So we're trying to find where they meet and their total distance would have been 200 miles. Okay, so how do I solve that?
You add like terms.
Add like terms. What's 55x plus 45x?
Isn't that 100?
Mm-hmm. Now what?
Divide by 100.
Now, we have to pay attention to what the question is. How long will it take them to meet? Does x represent my time? Yes? Yes. So, we know that this is 2 hours. Now, what if it would have said, how far did the 55 mile per hour car travel? Could we have multiplied 55 times 2? Yeah, okay, so always pay attention to what it's asking, okay, because that's what's going to be your answer. I might have you solve for time but ask you distance, okay, so you always have to pay attention to what it's asking, okay? Cell phones need to be put away. So you would put 100, like 55 times 2 is what? 110, so you'd say 110 miles. Does that make sense? Okay. So let's look at number 2. So it says 2 boats leave port, one heading east at 12 miles per hour and one heading in the opposite direction west at 10 miles per hour. How long will it take before the boats are 33 miles apart? So we know that they both start at port. Okay? We know, do you remember never eat sour watermelon? Never eat sour watermelon. Okay, so we know that east is the first one and it's going 12 miles per hour. Okay, so I know my first rate is 12. Do we know time? No, so we're just going to put X. And we know the other boat is heading west at 10 miles per hour. We want to know how long before the boats are 33 miles apart. So we know this one's rate is 10. This is X because it says they both leave. It doesn't specify if they left at different times or anything like that. So both of their time is X. Okay. So knowing that, we have 10 times X equals 10X. We have 12 times X equals 12X.
12x plus 10x equals 30 miles.
So we know that the green line plus the pink line equals 33 miles. So we have 12x plus 10x equals 33. What do I do?
Add like terms and then divide.
So when we add like terms, we get 22x equals 33.
And divide by 22.
Divide both sides by 22.
X equals 1.5.
Now, before we keep going, it says how long will it take the boats? How long will it take before the boats are 33 miles apart? So we want to know time. How long? Okay, so T, what represented our T?
X.
So 1.5. Now, 1.5, how do we write that in hours and minutes?
90 minutes. 90 minutes.
So we can say 1.5 hours, or you could also see it as 1 hour and how many minutes?
37.
Okay, the reason I write both, I don't care if it's open-ended and you write one way or the other, but tests are multiple choice, so I want you to be able to see the difference between the two different ways. Any questions with that one? Okay. So let's look at the next one. Jose, put your phone away. So it says a car leaves Houston heading east at 50 miles per hour. 1 hour later, a second car leaves Houston heading east at 65 miles per hour. How long will it take for the second car to overtake the first car? Okay, so when we want to know when it'll pass it, don't we need to find out when they'll be exactly the same? Because within less than a second, it's going to pass if it's going faster. So we're looking for where they've made it the same distance. Okay, so it says they started in Houston. Okay, and it says that the first car is going east at 50 miles per hour. Okay, then it says 1 hour later, so we know 50, and we don't know our time, so we're just going to put an X for right now. Then it says we're heading east at 65 miles per hour. Remember, we're looking for where they're the same, so that way we can figure out when the pink one will actually make it further than the green one. Okay, do we know the time here? No. But what does this say about time?
An hour later, so it would be minus 1.
So it says 1 hour later, a second car. Well, if it left 1 hour later, doesn't that give this first one a head start?
Yeah.
Of how long?
1.
1, so we could put plus 1.
So it would be 51?
No,
Or would it not?
that's its rate, not the time. So we know this, okay? Now we are going to multiply. So again, this one has a plus, so we actually have to distribute. What's 50 times x?
50
So yeah, you're right. So 50x, and then 50 times 1 is 50. And then down here, 65 times x is 65x. Now, do we even know the total distance?
No.
So we have no purple line here. But what do we know about the green and pink? They're equal. So can I set this distance equal to this distance?
Yes.
Yes. Mm-hmm.
Why do you put +1? Why don't you just put, like, you could have put +60?
Well, because time is in hours.
Oh, always an hour.
So it wasn't 60 hours, it was 1 hour. Does that make sense?
Okay.
Now, if you wanted to do minutes, you could, but then you'd have to convert your miles per hour to miles per minute. Do you want to do all that? Do you see what I'm saying? So that's why we always leave our time in hours, because our rate is in hours. Somebody had a question?
How do you know those two are equal?
Because our green line, we were talking about how we want, how long will it take for the second car to overtake the first car? Well, we can't set it to where we know when, but we can set it to where we know when they're equal, because as soon as they're equal, within seconds, won't this one go faster?
Yeah.
So let's find where they're equal, and we know right after that time, the pink one is going to be ahead.
Okay, thank you.
You're welcome. Okay, so knowing that, let's solve. What do we do to solve this one?
We get rid of 50 by minus 50. That's what we're just getting.
Okay, this cancels, and I get 50 equals 15x.
And then divide by 15.
Divide both sides by 15.
3.33. And
What
so on.
is that? Okay, so we know on 50 divided by 15. What is that as a fraction? 0.33333.
It's discontinuous.
It's a fraction. It's a pretty fraction, actually. Does anybody know? It's 1 over 3. Okay, so we could write 3 1/3 hours. Now, who can tell me what a third of an hour is? Not 15 minutes.
20.
It's 20. And I'll show you how I can figure that out. Doesn't 1/3 pretty much just mean divide by 3? So how many minutes are in an hour? Divided by 3 gives me 20 minutes.
So there's going to be a lot of variant problems. Like there's the one that's straightforward, like when they're going to pass over. One if they're seeing how far they'll be at that point. Then one see.
They're all going to be different for the most part. Okay, so let's look at one more together. So it says Maria and Mike are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Mike, since Mike lives 40 miles further away. Mike travels 5 miles per hour faster than Maria. Find the average rate. So this one's a little messy. There's a lot of information, so we're going to take it one at a time. So we know that they're both going to this business conference. We know that Maria takes 2 hours. So we'll say this is her house, and she takes 2 hours. Okay, so we know Maria's time is 2 hours. Do we know Maria's speed?
No.
So that's our first unknown. Y'all don't multiply for your distance until you're done going through everything in your sentences, okay? So then we have Mike, but we know Mike lives further away, so I'm going to draw his dot over here. And he goes this way to the same place, and it takes him 2.5 hours. So again, we know his time. Do we know his speed? No. What does it tell us about his speed, though?
He goes
Yeah,
5.
he's faster than me.
What do you think that needs, like what happens? What does 5 miles per hour faster? Plus, minus, multiply, divide, plus 5. Now,
Find their average rate.
what is this distance? What's the extra distance from Maria's start point and his start point?
40.
40 miles. Okay, that extra distance between their two start points, it tells us right here, is 40 miles farther away. Mike is 40 miles farther away. Okay, so let's go ahead and multiply. X times 2 is 2x. Now here we have this, so we have to distribute. What's 2.5 times x?
2.5 x.
And then 2.5 times 5.
2. 10, 15.
2.5 times 5.
Oh, 12.5.
12.5. Okay, so what do we know here?
Did you subtract 40? Or 12.5?
No. So we have the pink. What represents this top line? Well, the distance of the top line is 2x. What else is the distance on that top line? That plus 40. Okay, equals the distance of the bottom line, the green, so that's 2.5x plus 12.5.
Why do you add the 40 to Maria and then Mike if he's further back?
Because that's the distance. We drew him further back, but his time is more. So their distance that separates them is 40 miles, right?
Yeah.
So her drive plus 40 would be his drive. Okay? Okay, so now how do I solve this? Minus 2x on both sides.
And then minus 12.5.
So then you said minus 12.5. What does that give me?
27.5.
And then divide by 0.5.
And x equals what?
55.
Okay, so before we answer or box any answers, we come to the question. Find their average rates. R. What is Maria's rate?
2x.
It's just x. And what represents x?
50
55. So Maria
is 55.
drove 55 miles per hour. Now Mike's is x plus 5. Well, what's 55 plus 5?
60.
So Mike drove 60 miles per hour. Okay, I want you to realize not all of your practice problems are going to mirror these problems. They're not going to be exact. If I did an exact of all your practice problems, we would be here forever. Y'all get so annoyed of listening to me. So yes, there are going to be some different things. That's the whole reason, though, that you have class time today and all class time tomorrow to finish this so you can ask as many questions. Y'all, we post the answer key because we want you actually checking to see if you're getting it right. If you're getting it wrong, what should you be doing? Asking. Yeah, if you can't find your mistake, can you come ask me and say, hey, where did I mess up? Y'all, if you just erase it and try to start over, you're not understanding what you did wrong. Okay? You have to understand what you did wrong to learn. Okay? So make sure you're asking questions. Those of you online, I'm going to post my remind just in case you're not on it yet. And you can send me pictures. I think we did this yesterday in this class. But you can send me pictures of your work.